A quadrilateral is any four-sided shape, polygon. We have specific four-sided figures, but the quadrilateral is the general term for any polygon with four sides. The first one we're going to talk about is a parallelogram. And a parallelogram is a quadrilateral with both pairs of opposite sides parallel, and they look like that most of the time. So basically kind of like a rectangle that somebody squished sideways a little bit at the top. Has anybody ever put together like a bookshelf, and before you put that back piece on, if it can turn into like a parallelogram, it's like wobbly. So that's kind of the same idea. Like it's a rectangle, but it sort of slid over a bit. Okay. We have some theorems about parallelograms. The opposite sides of a parallelogram are congruent. So if we have our parallelogram, it's a nice straight lines, just pretend. Okay. Opposite sides are congruent, so this side is the same as that side. This side is the same as this side. Opposite angles are congruent. So this angle is congruent to this angle. Actually, let me change that. Okay. So this angle is congruent to this angle, and this angle is congruent to this angle. Okay. And then the diagonals of a parallelogram bisect each other. So I'm going to draw another parallelogram. So this is 41 and 42, and this will be 43. Okay, the diagonals go from corner to corner across like this. And this length will be the same as this length. And this length will be the same as this length. So the diagonals are bisecting. Now, this length, where am I? This length here is not necessarily the same as this length. It's just, if you cut the diagonal, then you get two halves that are even. I'm going to put this up here. Remember we had that formula? You take n times, whoops, sorry, I'm doing this backwards. Remember it was 180 times n minus 2 for the angles. So all the quadrilaterals is going to be 180 times 4 minus 2, which is 180 times 2. So every quadrilateral will be 360. Angle sum. And then I wrote over it, but consecutive angles of a parallelogram are supplementary. So I'm going to have to erase my pictures here real quick and draw them smaller. So bear with me. I'll pause again. Consecutive angles are supplementary. So if I have my angles and I have these two are the same, right? Those are congruent. And then these two are congruent. What we're going to have is plus blue will equal 180. So I can add these two together, or these two, or these two, or those two. As I go around, as any two will add up to 180. Yeah. Which makes sense because the whole thing's 360 and two angles are half of that. But they have to be in order. So these two, the two blue ones, won't necessarily add up to 180. As a matter of fact, in a regular parallelogram that's not a square or a rectangle, they will never add up to 180. Yeah, they just equal each other. So let's talk about, here's a parallelogram, ABCD, that's this parallelogram, with E as the center of the diagonals. We have parallel lines. We have congruent opposite angles. We have diagonals that bisect each other, and then these are the consecutive angles that would add up to 180. Okay. So we're going to use these properties to solve for x, y, and z. Okay. Now, this side is the same as this side. This side is the same as this side. This angle is the same as this angle. This angle is the same as that angle. These two angles add up to 180. Okay, so what do you want to solve for first, x, y, or z? Okay, we'll go alphabetical, x. So I have this angle and this angle are my x's. Because they're not opposite, they're not equal, they add up to 180 because they're consecutive. So I have 10x minus 20 is equal to 180. I'm going to add 20 to both sides. I have 10x is equal to 200. Divide both sides by 10, and I get that x is equal to 20. Okay, so there's x. Next we'll do y. These sides are opposite sides, so they are congruent to each other. I'm going to subtract 3y from both sides, and I get 2y minus 6 is equal to 4. Add 6 to both sides to get that 2y alone, and I get 2y is equal to 10. Divide by 2 for a y to equal 5. So far okay? I could do plus 6 first and then minus 3y, yeah. I just me personally, I tend to move the variables first, but you could move the 6's first, that's okay. You get the same result. The only thing you can't do is move them all to the same side. You have to move them to opposite sides. And then finally, I have c, 3z plus 8 equal to 5z. I'm going to subtract 3z from both sides because there's no numbers over here. So I get 8 is equal to 2z. I could have subtracted 5z from both sides, but then that would have left me nothing over here, so I had to make sure I put a 0 as a placeholder. Divide by 2, and z is equal to 4. So there we go. I've solved for x, y, and z. Now on these particular problems, you're either going to have things are equal to each other, or they're going to add up to 180 if they're consecutive angles. Not a lot else going on. Maybe? Oh, darn it. I'll delete that in a minute. All right, so angle ADC and ABC are what? I have ADC, that's this angle, and ABC, that's this angle. What is their relationship? Congruent. You could have also put opposite because they are opposite to each other. Both of those answers are true. If AC, that's this part right here, this whole thing is equal to 26, EC is how long? Yeah, we're going to take 26, we're going to divide it by 2, and that gives us 13. Okay, DC, that's this length here, is x plus 18, and AB is 3x minus 4. I know that these two sides are congruent, so I set those equal to each other. Oh, whoops, no, that's wrong. I didn't read the whole problem, did I? X equals 11, but look, I want to find the length of DC. DC is x plus 18. So this is 11 plus 18, so 29. Yes? You're in the packet. This is just notes, not the same. Yeah. Okay, on this one, DAB is 113, so DAB, that's this angle right here, is 113. What is ABC? I know, no, ABC, this angle here. Okay, so what do I know about these two angles? They're not congruent because they're next to each other. They're going to add up to 180. Yeah. So I'm going to do 180 minus 113. And so 180 minus 110 is 70 minus 3 will give me 67. If I tell you any one angle in a parallelogram, so let's say I just tell you that this angle here is 105. And then I say find all the other angles. This one is very easy. And then for these two, you would say 180 minus, and so you'd get 75 and 75. Okay? Any questions on that? No. But oh, no, not you. Hold on. Let's move on. We have a couple more theorems. If both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. Okay, this is just the backwards of what we were talking about before. Okay? So if we have this, then it's a parallelogram. If you have a parallelogram, then you have this. So that goes both ways. That's all this is. If one pair of opposite sides are parallel and congruent, so you have to be parallel and congruent. If you're both parallel and congruent, you're a parallelogram. If both pairs of opposite angles are congruent, so if you have this is the same as this, and this is the same as this, then you're a parallelogram. If 1 plus 2 equals 180, you're a parallelogram. If consecutive angles. And then if the diagonals bisect each other, you're a parallelogram. So basically it's everything that we talked about as if you're a parallelogram, that means these things, except you're going backwards. If you have these things, then you are a parallelogram. The only thing that we didn't have on here, or before, was this one. This one's new. But the parallelogram, we said that the opposite sides are parallel, and we said the opposite sides are congruent. But we said it was both pairs of opposite sides. But to prove or to show that a quadrilateral is a parallelogram, you only need one side. One pair, rather. Not one side. One pair of opposite sides. So you could have this, or you could have these two. You don't need all four to show. Does that make sense? Okay, so we're not going to actually do proofs, but if you were going to do these proofs, this would be how you would prove something as a parallelogram. You'd have to prove that both pairs of opposite sides are parallel. So you would need this side parallel to this side, and this side parallel to that side. You need both pairs. You'd have to prove that both pairs of opposite sides are congruent. So you would need this is congruent to this, and this is congruent to that. You would have to prove that one pair, so either this set or this set, are parallel and congruent. You'd have to prove that the opposite angles were congruent. Or you'd have to prove that consecutive angles added up to 180. So 1 plus 2 would be 180, 2 plus 3 would be 180, 3 plus 4 would be 180, and 1 plus 4 would be 180. Or you'd have to show that the diagonals bisect each other. So you'd have to show this length was the same as this one, and this length is the same as that one. So you have to have one of these things, one of these 6 things, to say, yes, this is a parallelogram. Okay, but we are going to have to do this. So let's go back for a second and remember this old guy that we used to do? Distance is equal to x1 minus x2 squared plus y1 minus y2 squared. Now, I'm going to show you 2 ways to do this. I'm going to show you how to do this using the distance formula and slope, and then I'm going to show you how to do this using graph paper. Okay, distance formula and slope. Well, first I'm going to go ahead and put it on graph paper. Here's point A. Okay, here's A. B is 2, 4. So here's B. C is 8, 4. So here's C. And D is 6, 0. So here's D. Okay. So here's our parallelogram. Actually, I'm going to make that a different color. Okay. So here it is, all nice and pretty. We need to make sure that this line is parallel to this line, or that this line is parallel to this line, and they're the same length. I don't have to do all four. I have to do one pair, but I have to show they're the same length and that they're parallel, so they have the same slope. Okay? So you can either do AB and CD, or you can do BC and AD. Which set would you like to do? This is actually the easier choice. Yeah, we're doing AD and BC. These two sides, okay? So we're gonna try to prove that this is the same length as this, and that these are parallel. Okay, so slope. I do 2's minus 1's, but you can do it either way. Okay, slope. Y's over x is 4 minus 4 over 8 minus 2, and so I have 0 over 6, so my slope is 0. And then I have, this is the BC slope, AD, I have 0 minus 0 over 6 minus 0, 0. So they are parallel. I did prove, well, I still have to make sure they're the same length. Okay, so yes, parallel. Okay, now I do the distance formula. x1, so 8 minus 2, plus 4 minus 4 squared. So that's just 0, right? 0 squared is just 0, so I'm just gonna be like, okay, that's 0, whatever. We're done with that part. It doesn't matter. I just did this one minus that one. If I do this one minus this one, or this one minus that one, it's okay, as long as if I do 8 minus 2, well, I do this 4 minus that 4. Do it in the same order, but it doesn't matter which one you do first. I just did that because it's bigger, so it subtracts nicer. So I have the square root of 6 squared. What is the square root of 6 squared? No, the square root of 6 squared. 6. The square root of 6 squared. 6. If I take a square root of a number that's squared, the square root and the square cancel each other out, so it's just 6. This is the square root of 36, which is just 6. But you can skip this step if you still have this in there, and it's by itself. So this length is 6, so I need to make sure this length is 6. Well, if I go from 0 to 6, what is my length? 6. Done. I proved that they're parallel. I proved that they're congruent. So yes, it is a parallelogram. Now I'm going to show you another way to do that. Okay, so I have 0, 0, 2, 4. Oops, 2, 4 is not on 0. Sorry. 2, 1, 2, 3, 4, 2, 4. And then I had 6, 0. And 8, 4. Okay. So this was A, B, C, D. Now I'm going to go A, B, and CD this time, because I want to show you, because sometimes it won't line up flat like this. The parallelogram could be like, you know, crooked, sideways in the thing. So what you do is you pick, okay, this is one side, this is another side. I'm going to prove that these are the same length and have the same slope at the same time. I'm going to use right triangles. Okay, slope is rise over run, correct? Well, this right triangle, here's my rise, and here's my run. Okay, here's another triangle, rise and run. If these number of spaces are the same, then I know the slope is the same, correct? I also have right triangles, and remember the Pythagorean theorem, so I say a squared plus b squared equals c squared. If these two lengths are the same as these two lengths, then the third side is also the same. Does that make sense? Because I'd be having a right triangle with like, well, here, let's do this. This is 1, 2, 3, 4, so I have a 4, and then I go 1, 2, 2. I'm going from 6 to 8, or sorry, from 6 to 8 this way. So from 0 to 4, 0, I go up 1, 2, 3, 4, and then I'm going from 6 to 8, I'm going over 1, 2. My slopes are the same. And if I figure out the length of this, this is a right triangle with legs of 2 and 4, and 2 and 4, then that means the hypotenuse, which would be the square root of 2 squared plus 4 squared, would be the same. So by putting it on graph paper, all I have to do is count the right triangles from this corner to this corner and this corner to that corner. And if this height is the same and this length here is the same, then they are parallel and the side lengths are the same. And I didn't have to calculate. All I had to do was count. And I'm using properties of slope, and I'm using right triangle Pythagorean theorem to know that these lengths are the same. So if you count the same number of spaces from here to here as you do from here to here, then they're parallelogram. So you can do the math, the distance formula and the slope formula for both sides, or you can graph it on graph paper and then count. Oh, I was doing different. I was doing these two sides, not this side. Yeah. You have to do, yes, you have to do the slope formula for both sides and the distance formula for both sides, because you have to prove that they both have the same slope and they both have the same length. So you'll have to do 2 distance formulas and 2 slopes. And I'm doing that by making this right triangle. This is the slope. The slope is 4 over 2. I am finding the slope. I'm just not actually going all the way, but I'm seeing that they have the same slope because they have the same going up as they do going over. Same rise over run, so that makes them the same slope. And then because it's a right triangle, I know that this length is the same as that length. So I'm finding the I'm not finding the distance, but I'm showing that the distances are the same. So it's the same principles, it's just a different way to approach it, if that makes sense. Go over this real quick. Find the value of an x and y that will make this a parallelogram. What does x have to be? What does y have to be? None. Okay. What does y have to be over here? Okay. Now this one is going to require some calculation. Because this is 26, I know that this is also 26. And I know that this whole thing plus this, these two together are going to make 180. So I'm going to have to do 180 minus 117 and minus 26. So I can add the 117 and the 26 together and subtract it from 180. So that's going to be 3, carry my 1, 143. So that is going to be 37. is my x. Does that make sense? So that one took a little bit more work. Here we have, I'm going to just do one of these because we're running out of time. So do you want to see C or D? I think D is probably going to be the more challenging one. Okay, so. I have a 2, 6. Oops, 1, 2, 3, 4, 5, 6. I don't know why I put a dot down here. Ignore this one. A 3, 7. So that's only one up from there. A 5, 12. And a 3, 11. Okay, looking at that right now, do I have to finish this at all? Can you, I mean, you can tell just looking at this that is not a parallelogram, right? It's this length is longer than this length. Here, I'm going to erase all that again so you can kind of see what I was talking about. Okay, but if we wanted to go through it, but I'm going to go through it and double check and just show. So see, we go up 1 over 1, and here I'm going up 1 over 2. Because I went 1, 1 and 1, 2, not a parallelogram. Okay, I'm going to do A, because actually we do have time for me to do A real quick. I'll do it in blue. 0, 0, 1, 2, 3, 4. Okay, 10, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 and 7, 0. Okay. So I go from here to here, I'm going to go up. I'm going up 1, 2, 3, 4, and I'm going over 3. From here, I go up 4 and over 3. So 4 and 3, 4 and 3. This is a parallelogram. And if you guys want me to go over these tomorrow with the distance formula and the slope formula, I'll do that. Just remind me. Yep. They just have to match. So you can see how the blue set matches, but the red set doesn't. So, hold on, I'll get it for you. Let me just write down your homework real quick. Your homework, yes, you have homework, is page 39, 1 through 11, and page 40, 1 through 14. Hold on, I didn't finish. Odds.